Hi, my name is Landon Kingsley, sophomore at Bremen High School, and this is my Governor's Honors Program video submission. What is an interesting topic I have studied recently in mathematics, either in class or outside of class? One topic I found to be interesting is aerospace mathematical engineering. This is a combination of different algebraic, physical, and even some chemical equations, and bring them in this big crock pot to see how the changing of variables, such as different weights or different materials, will affect the flight of a rocket without actually wasting these materials and time, but still getting accurate results. Why does this topic interest me? This topic interests me because, in layman's terms, it's fun. Not only solving each problem, but seeing each equation, each pencil stroke come to life in a sudden burst of power as the rocket lifts off the ground. Watching what you have put your time and soul into to be true, and knowing without a shadow of a doubt what will happen, is a rush unlike any other. What are my interests in mathematics outside of my regular mathematics class assignments? As I've stated, my goals are not strictly, but specifically in the field of aerospace. I can easily see myself becoming an aerospace engineer. In fact, I keep this notebook here, full of all of my notes, equations, and examples to look back on later in my career. Aerospace engineering is crucial for the future and betterment of humanity, whether it be finding new planets and materials or uncovering other secrets of the universe. What is a difficult math problem I've encountered within the last year? This problem all started with a question. How far does the Earth travel in one revolution around the Milky Way? Now you'd think all you'd have to do is take a point from the center of the Milky Way, draw a line to the Earth, and do 2 pi r. But no. See, as the Earth makes its way around the galaxy, it makes smaller revolutions around the Sun. And even around the Sun, it makes even smaller revolutions with the Moon, as their gravity affects each other. And I just couldn't wrap my head around how to find this total distance. How long did I spend working on it? Well, I'm still in the process of figuring out how to solve this predicament, but I have learned many basic knowledge things to help me understand it, which leads into the next question. What approaches have I used to solve or attempt to solve the problem? I actually have a diagram over here. Now, why is this diagram important, you may ask? Well, using the visual aid, we can use this to find simple trigonometric ratios. This helps us find ultimate distance. For example, knowing that sine of angle A is line MT over line OM, or opposite over hypotenuse, we can infer that to find line MT, we would first need to find line OM and multiply it by the sine of angle alpha. Similarly, to find knowing the cosine of angle alpha is equal to line OT over line OM, or adjacent over hypotenuse, we can infer that to find the distance of line OT, one would first need to find the distance of line OM and multiply it by the cosine of angle alpha. Since I took Algebra 1 in 8th grade, I started off my freshman year with geometry and ended the class with a 99. Then, my second semester, I did Algebra 2 and ended that class with a 100. My sophomore year began with AP Pre-Calc, and I ended that class with a 97. And I am currently enrolled in AP Calculus AB, and currently have a 100 in that class. And I hope to add the Governor's Honors Program classes to that list. Thank you for your time and consideration.